Hey guys, today we're going to start looking at adding and subtracting polynomials. And polynomials, that's just a fancy way of saying an expression. So for example, this, if you have one term, is called a monomial. Mono means one. If you have two terms, that's a term is separated by a plus or minus sign, that's called a binomial. And then you keep going. If I had another term, that would be a trinomial, and usually after three we just call it a polynomial. Poly means many. Now I do want to remind you of one thing as we get started. When we're adding and subtracting polynomials, we're doing nothing more than combining like terms. And just remember, we only combine like terms that have the same variable or letter to the same power. So the first thing you're going to do is make sure you have a plus sign in the middle. If you have a plus sign, all you do is combine like terms. So I have 7n and 3n. That combines to give me 10n. And then I have two constants, 2 minus 8. And 2 minus 8 is negative 6. So 7n plus 2 plus 3n minus 8 combines or simplifies to 10n minus 6. Let's try a few more. So let's take a look at this one. 4n squared minus 11n plus 5n squared minus 4n. And I do also want to tell you that when we simplify, we always put the number with the highest exponent first. That's going to be our leading term, okay? I do have a plus sign here, okay? That's very important. So now all I have to do is combine like terms. I have 4n squared and 5n squared. Those are alike, same sign, so I add and keep the same sign, 9n squared. And then I look at negative 11n minus 4n. Same sign, so I add the numbers. And you can type that straight in the calculator. Negative 11 minus 4 is negative 15, and n is what made them alike. So your simplified expression or polynomial is 9n squared minus 15n. And I do want to tell you another term. Once you have these in order, see I have n squared, then n, the number up front is called your leading coefficient. That's going to be important as we get further into this. So my leading coefficient here is 9, and you keep the sign, it's positive 9. Let's do one more adding polynomials. So let's say we have, let's do two more. Let's say we have 6n squared minus 5n plus 1 plus n squared plus 9n minus 8. So first, do I have an addition sign in the middle? I do, so all I need to do is combine like terms. So I usually start with the first thing I see, and the first thing I see is my n squared. Is there another n squared in the second set of parentheses? Yes. There's no number, but that's an understood one. So 6 plus 1 is going to be 7n squared. The next term that I notice is negative 5n. Is there an n in the second set, or the second parentheses? Yes. So negative 5n plus 9n is going to be positive 4n. I'm using my integer rules to help me combine. And now I have two constants, plus 1 and minus 8. My signs are different, so I subtract, keep the sign of the bigger number, so negative 7. So my simplified polynomial is 7n squared plus 4n minus 7. My leading coefficient in this case is 7. Now let's do another one. 12n cubed plus 3n minus 3 plus negative 5n squared minus 3n plus 16. Now, if you'll remember, I told you that the most appropriate way to write these is in descending order, meaning you start with the highest exponent and go to the lowest. So first, I see I have a plus in the middle, so that means I can just combine like terms. Now, I'm not going to highlight these so you don't get confused. Well, maybe I will. That's okay. I think it helps. So looking at these two, the highest exponent I see is to the third power, n to the third power. I don't see anything with n to the third power anywhere else, so I'm just going to bring that down. What comes after n to the third when you're going down? Well, n to the second power. And I only see n to the second power in the second set of parentheses. There's nothing to combine it with, so I just rewrite it. Let's keep going. I do notice 3n minus 3n. Both of those are n to the first power, just plain old n. 3 minus 3, that makes that cancel. And then I'm left with negative 3 plus 16. Those are like terms. They're both constant, so negative 3 plus 16 is positive 13. So I have a trinomial, you can still call it a polynomial, 12n to the third minus 5n squared, or to the second, plus 13, and my leading coefficient is 12. So what do we do if we have subtraction? Let's try a few of these. So let's say we have 5k plus 16 minus 2k plus 7. Remember, in the first four examples, I said the first thing you need to look for is, do I have an addition sign? Well, if you don't, you have to change it. And the way you do that is keep the first. This is really like distributing a negative 1 through. So when I multiply everything to change it to a plus, it's like you change it to a plus and all the signs after it change. But the reason is because you're distributing a negative 1 through. So this becomes a negative 2k, negative and a positive becomes a negative 7. See that? The minus changed to a plus and all the signs after it changed. Now I do it just like I did the first four examples. I combine like terms. So the first thing I see is k. So 5k minus 2k is 3k. And then I have 16 minus 7, which is a positive 9. So this subtraction, when you subtract polynomials, it ends up being 3k plus 9. My leading coefficient is 3. That's my first coefficient there. So my leading coefficient is 3. I'm sorry, I might have said 9. Let's do a few more of these subtraction problems. So let's do 15k squared plus 4k plus 2 minus 8k squared minus k minus 8. So again, I do notice that I have a minus sign in the middle, so the first thing I want to do is deal with that. So 15k squared plus 4k plus 2. This becomes a plus, and all the signs after it change. Minus 8k squared plus k plus 8. And now I can just combine like terms. So I do notice I have in both sets of parentheses k squared terms. So 15k squared minus 8k squared is 7k squared. And I'm just going to keep going down. After k squared would be k. So I have 4k plus k. Remember, there's an invisible 1 there. 4k plus 1k is positive 5k. And, excuse me, my constants, 2 plus 8, will be a positive 10. So that is my simplified expression. 7k squared plus 5k plus 10. What's my leading coefficient? 7, because 7's in front of my highest exponent, or that's called the highest degree. Okay? Let's try a couple more of these subtractions just to make sure you're okay. So 9k squared minus 4k plus 1 minus 9k squared minus 6k minus 7. I do notice I have a subtraction sign. That's the first thing you should look for in all of your problems. If you have a subtraction sign, you've got to do this first. 9k squared minus 4k plus 1 plus, and then change all the signs after it. Positive 9k squared becomes negative 9k squared. Negative 6k becomes positive 6k. Negative 7 becomes positive 7. Now I can combine my like terms. First, I notice I have 9k squared minus 9k squared. Well, that's 0, so I don't have to write down anything. That cancels out. Next, I see that I have negative 4k plus 6k. Negative 4 plus 6 is negative 2k. And I notice I have 1 and 7. Those are constants that can be combined to give you plus 8. So negative 2k plus 8 is your simplified expression. What's your leading coefficient here? Exactly. Negative 2 is your leading coefficient. Now let's try one final one. So we have 7k squared minus 6k minus 2 minus negative 4k to the 4th plus k plus 9. First thing I'm going to ask, do I have a plus sign between my parentheses? No. So I need to change it to plus. So this becomes 7k squared minus 6k minus 2. Notice nothing changes in the first parenthesis. But now, to change this to a plus, I have to change all the signs after it. I'm multiplying everything by negative 1. So negative 4k to the 4th becomes 4k to the 4th. K becomes negative k, and 9 becomes negative 9. Now I can combine my like terms. This one's a little tricky. I see a k squared, a k constant, a k to the 4th term, and then k and 9. So following our rule of putting the highest exponent first, I'm going to bring down the 4k to the 4th. And that's it. I can't do anything else with that. Do I have anything with k to the 3rd? No. K to the 2nd? Yes. I notice, let me do green. I notice I have 7k to the 2nd, and it's positive, so plus 7k to the 2nd. Do I have anything with k to the 1st? Yes, I do. I have negative 6k and negative k. So negative 6k minus 1k is negative 7k. And last but not least, negative 2 minus 9. Both are constants, and you end up with negative 11. So our polynomial, or our simplified expression, is 4k to the 4th plus 7k to the 2nd minus 7k minus 11. And what is our leading coefficient? Our leading coefficient would be 4, because that is the term with our highest exponent. So our leading coefficient is positive 4.